right. Here we go. Still working on this. Here we go. Oh, crud. I see that it is backwards. Is it mirrored? Yeah, it's mirrored, so I guess there's got to be a... where can I change that? Wait, that is on yet. I got 2 people on it now. All right. If you can see the questions, I'm still trying to figure out how I can flip this back around. Something. HP.
What is this?
Oh,
I never clicked on that.
What does this do?
I don't know. Did it do anything? Click.
Oh, share copy. Good. All right, got 4 people up. Oop, cancel. All right, who's here? All right, so I got a problem that I've been working on. We're going to see how this goes. Can't really see who's... Ah! Why would you leave that on there? No?
That's only if you type in the chat.
Oh, okay. All right, I got people on. So here we go. This is problem number 21. The 3 charges. Can somebody make a comment to see if it's mirrored or not? On my end, it's mirrored. I can't figure out how to switch that around. This did not happen yesterday, by the way.
Oh, it might have been. We didn't write anything yesterday.
That's true. I didn't write anything. All right. Is the image mirrored? We do what? Yes. Ah, crud. All right. Thank you, Kaushik. Let's see if we can get this. Where would that be? Not such a surprise.
I don't know.
Oh, never mind. Oh, looks fine to me. Okay. So, okay, here's question number 21. I've got 3 charges here. Let's take a look at what the net force on them is going to be. Oh, a couple things before I get started. Officially, AP testing is going forward. I got an email yesterday from the College Board. So we're going to move forward as this is still happening. I've got it at about a 50-50 chance that it doesn't, or at least gets pushed back. Physics Bowl was canceled, so they're refunding my money. The F equals MA exam has been pushed back to April 28th. So I think this is kind of what's going to end up happening. So as we're kind of just, it's a fluid situation, and we just keep going forward with what we know right now. So yeah, here we go. Let's take a look at, if you have any questions, you can even type them into the chat, or I don't know where else, what's going on. Okay, here we go. So question is the 3 charges that are in an equilateral triangle. And so the charge is...
Not learning, are you?
Yeah, there we go. That's my wife's grandmother's talking clock. No, it's flipped on my screen, so I can't figure this out.
Oh.
This is what a talking clock looks like.
It's 11 a.m.
All right. Oh, also, no, that's all right. We'll just kind of keep rolling here. So trying to find the net force on both of those. So because it says net force, that means free body diagrams. Let's do A first. So I'm going to do A first. I'm going to have the positive or negative and positive. These are opposite directions, so it's going to attract. This is the force on A from B. All right, you can see it. And this is going to go, that's negative and positive. That's going to go that way. That's the force on A from C. Right, and I know that this angle is, this is a 60, 60, 60. This is 60 degrees. This is an equilateral triangle, so that's 60 degrees. All right, here we go. So I'm going to need so let's see if I can figure out what it's just magnitudes of the forces. I believe that's what we're looking at. I have that here in my other quad. Yeah, I want to look at. Yep, calculate the magnitudes. Okay, here we go. So I need a axis in order to make this happen. So I'm going to pick the one that goes this way. Just to kind of see this easel that I made. It's a side of a piece of IKEA shelving that I attached some old tire chains to. A bit closer. There we go. And nice view of my house. All right. So we're going to sum the forces in the x direction and then sum the forces in the y direction. In the x direction, the x, here's the y, this way is positive, this way is positive. I'm going to have FA caused by C, and then I'm going to have this FAB in the x direction, FAB in the x direction. I need some T here in a moment. The FAC in the x direction, and those are both positive, so the sum of the forces in the x direction are going to equal FAC plus FAB in the x. FAC is two charges, K, Q, Q, all over the distance between them squared. So I've got 9 times 10 to the 9th times Q1. All these, the ones that I have here are 4.4 microcoulombs. 4.4 times 10 micros minus 6. And then 4.4 times 10 to the minus 6. Divided by the distance between them squared, I've got 2.4 centimeters. That does have to be in meters. So I've got 0.024, that sounds right, squared. That's going to be a C. Where's my calculator? Here's my calculator. While some of you are calculating that out, I'm going to do it in the FAB in the x direction, which is going to be FAB. Oh, God, I want this part. That's the cosine. Cosine 60 degrees. I think that's right. Sine, cosine, yes. And then FAB is going to be 9 times, let me write that again. K, QA, QB, all of this is between squared. Cosine 69 times 10 to the 9th times 4.4 times 10 to the minus 6 times 4.4 times 10 to the minus 6. All over that 0.024 squared. Yeah, da, 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 da. Times cosine 60. Yes, Sparks, this is number 21. Let me write this up here. This is on it's WebAssign number 21. Yeah, the problem in the book. It's chapter 18, number 72. If you ever book around. Kaushi's question is, why don't we multiply by the charge of the electron? Because we were not given an electron. We were given a charge in the problem. So each charge was 4.4 microcoulombs. So, what am I doing on the page? Oh, you can kind of see. Now we got to do some math. Oh, this is nice. This is the same as that. Let me see if I can knock this out. Whoops. Here, inside. Totally know what I'm doing. 9 e negative 9 times 4.4 e to the negative 6 or e to the negative 6 divided by the quantity 0.024. All right, so I got this 3.025 to the negative 16th. So 3.025 times 10 to the minus 16th. That's AC, and then plus 3.025 times 10 to the minus 16th times the cosine of 60. Cosine of 60 is 1/2, I believe. 1.5125. Which then is going to give you 4.5 4.535 times 10 to the minus 16th newtons. Please let that be what it's. Why did I screw that up? Okay, something's wrong. Oh, that's because I took it times 10 to the minus 9. Now you don't like to see that. That doesn't seem right. Good, all right. Let me try this again. 9 times 9 to the 9th times 4 e to the 6 There we go. That's much better. Times 1/2. Wait, not 1/2. Okay. Oh, okay. That sounds about right. So here we go. That gives me 453 newtons. 1, 2. There we go. 453 newtons in the X direction. Now I have to go in the Y direction. I'm going to change colors. In the Y direction, I have 0 from in the AC, and then FAB in the Y direction is going to be times the sine of the angle. FAB in the Y direction is the sine of the angle. So here we go. That's going to be this 302 number. It's 9 times 10 to the 9. Again, it's K, Q, A, Q, B, all over the distance between them times the sine of 60. I'm going to have to get an equation sheet. Uh, 302 and a half times the sine of 60. Is that root 3 over 2? Times 2.5, 2.5, 261. 261 point. That's 262. All right. This is in the. What happened to FBC? We're not there yet. Thus far. So this is in the X direction. So I have something going this way at 453. This is going up at 262. Our net force is going to be in this direction. This is what force the net, the sum of the forces on A are going to be in that direction. So the magnitude of that is Pythagoric. 453 squared plus 262 squared. All right. So I got square root. 453 squared plus 262 squared. 523. 523 newtons. That is the sum of the forces on A. Yay! Let's do B. So now we're going to do some of the forces that are on B, the net force that's on B. What's nice is a lot of this is still the same. So now we're going to draw, again, our free body diagram on there. So I'm going to have a repulsive force from C. There's FBC. And then this is going to be attractive. Right? BA. Now you do the whole thing again. What's nice is, however, is that we can pick our axes a little bit nicer. So let's see here. Can I do this such that, yeah, I think so. Since I have magnitudes, do I like that one? Yeah, let's do this one. And then on the next one, I'm going to switch around to, I'm going to pick a little different axes. Let's see here. That is, this is 30 degrees. Is that right? That one is the same as that one. Nice. That's 30 degrees. That's 60. So that one's also 60. All right. So, I'm going to have sines and cosines all over the place. I'm going to switch that around. I'm going to make it go this way. I think it's 60 degrees. Yeah. 60, 60, 60. That makes this. This makes this 60. So if I make this my x-axis, there's my x. Yeah, this starts to get a little bit tricky. So here we go. Woo-hoo! I'm going to redraw this. Here's B. It's getting pushed that way and that way. This is F, B, C. This is F, B, A. And I want the sum of the forces in the x direction and the sum of the forces in the y direction. Now I need x's and y's. It's there. This is going to go here. This is now 30 degrees from my drawing up at the top. It's going to take a little bit of algebra in order to get yourself there. So in the x direction, I have F, B, C in the x direction and F, B, A in the x direction. F, B, C in the x direction is 0. That's why I picked it. So that way I don't have to mess with that at all. So in the x direction, BA in the x direction, it's going to go this way. So this is FBA in the x direction. I'm going to make this way positive and, well, okay, we can make it if this way is the positive direction, that one's in the negative direction. Negative FBA, that's cosine, FBA, cosine 30. FBA is KQAQB all over R squared. I solved that already here, which turns out to be FBA is 302.5. Negative 302.5 cosine 30. So the sum of the forces in the x direction are going to be 0 minus 302.5 cosine 30. So, okay, cosine of 30. I'm going to need my sheet. Somebody probably knows what it is. Oh, it's root 3 over 2 again. Times 3 over 2. 261. Negative 261 newtons. Good job, Sparsh. Okay. I think that's right. Let me double check that. I want to say yes. Here we go. Now I've got my x direction. Now I need my y direction. In my y direction, I've got FBC in the positive. Let me switch colors. FBC. And then I'm going to have minus FBC in the y direction. which is going to be, wait, FBA, I'm sorry, FBA in the Y direction. So some of the forces in the Y direction are FBC, which is K, F, B, C, K, Q, B, Q, C all over R squared, because they're all the same distance away. Should end up being 302 again. Is that right? That's the same, that's the same, that's the same, that's the same. Yes, 302. BC is 302.5. But now I'm minusing because I'm going this way. And that's going to be FBA, which is 302. Now I want the sine of 30. Sine, so I guess, which is sine of 30 is 1/2 again. All right. Thank you, Euban. I have to, maybe if I got out of the picture. It takes you the Y directions do not cancel out. Yeah, all right. Let me see if I can figure this out. Oops. I totally don't know what I'm doing. All right. Wait. All right, so I will be getting a little bit better. Hatice, yes, I did change the axis to a lineup with the otherwise to a lineup on one of the forces. This is a was.